All right. Good morning, everyone. Hello, hello. Hopefully, everything here is working. I had to reset up all my loop deck and streaming stuff, as you know, because I'm on an M1 Mac, and as things get updated, then things break. So hopefully everything's working. Also, I set up a work cam. See this thing, so we can see we can look at stuff today, which is good. So I got that working again. All right. Well, I am super excited for today's stream. We've got a lot of stuff to do. We're going to. I've got basically two kind of major goals today. I want to so we got our the GPS GNSS board back. You can see, so got them back from fabrication, and then Willow assembled them. This is what it looks like without the e-paper screen. That's what it looks like with the e-paper display screen. They're gorgeous. I mean, they're really, really gorgeous little PCBs and very compact. It's very cool. Honestly, I'm very proud of these. So we have, that's the USB. So recall that we used, let me pull them up. So recall that when we created this, we used these hardware add-on modules that we've created so that you can quickly get to like kind of field prototype with core compute modules. And in this case, we used the USB and boot buttons one, and then there's the core compute module. And then this is for solar panel, solar power, battery charging. Note there's a solar power plug-in, and then we've got our onboard IMU, the inertial movement unit or whatever, accelerometer, and then we've got our GPS chip and external antenna, and then we have a BME 688 for temperature, pressure, humidity. So yeah, I'm really excited about those. I think they're just beautiful. They turned out really good. So we've got two main things. One, I want to fix the enclosure a little bit. So there's two things with the enclosure. So this is, let me show you. Here's the enclosure. So there's got two issues. One is that when I designed the mounting holes for where the PCB sits, I didn't provide enough space underneath them. I actually provided enough space for the through holes for the e-paper display screen, but I didn't. The antenna, it turns out, is a little taller, so those. Yeah, so it doesn't quite fit in there. So if I do try to put this in here, it'll actually I can put it in and it gets stuck. So I'm not going to do that. So we're gonna fix that real fast. That should be super easy. And then the other thing that I did that's wrong is that the display on there isn't quite, the portal isn't quite centered. So that's what it should look like, but it's actually, I had it backwards in my head when I put it on, so it's off by 1/4 of an inch or so. So we need to update that, and then on the next version of the PCB, we'll move the displays, the e-paper display over just a hair. So you always find stuff, and then we're going to actually test out the hardware. So I haven't tested this hardware yet. All I've done is on one of them, I've made sure I could deploy Meadow-OS to the device, and as I do that, it deploys a Blinky app. So that worked. So we actually can communicate. So I think that it's, you know, that part's assembled correctly, but I haven't tested any of the hardware. So that'll be fun. We'll test that together, and we'll see what we get there when we test it. We'll see if any of the hardware goes awry. All right. So without any further ado, let's get into it, shall we? So let's go make this. Let's first make an adjustment to this guy. So this is our enclosure, and it looks like what we printed, which is cool. Okay, so I'm gonna edit the bottom. I'm gonna hide the top, and then I'm gonna hide the PCB for now. And hopefully this is like an easy fix. So I'm going to go to parameters. Somewhere in here I have the clearance on the PCB. PCB bottom clearance. All right, so I've got it set for 2 millimeters. And let me get my trusty digital caliper out, and let's measure the bottom of this. So, oh, that's inches. Millimeters. Okay, zero it out. So we need probably, looks like minimum is 2 1/4. Let's make it 3. 3. Boop. Hit OK, and then it's gonna recompute everything. And hopefully I did this right, and that won't screw anything up. It actually looks like I did screw something up, because if you see here that it cleared it, but it looks like when I positioned the PCB, no, actually that could be right. That's still centered. And that's, oh no, that looks correct. Cool. Hey, all right. I did it right. I did it correctly. Let's save that. And let's get it printed. So let's start that printing. Simplify 3D. This is these are cool. I had to print some more of these. This is what I use to prop everything up on my desk with. So if you see these, they're super helpful. They're actually a phone and tablet holder. So that's what you see. I use them for the phone, but I use them for everything. They're pretty rad. All right. And let's see. I'll show you where that's at. We'll take it. We're like 2 minutes into the stream, and I'm already taking detours here. All right. Here's Thingiverse. They're awesome. I'm only gonna do this because they are so cool. My likes. Boop boop boop. There they are. This is it. So I'll put this in the chat. so you can print that at home. Julian, good morning. Jorge, good morning. Okay, so now you can print those awesome little things. All right, let's however get rid of that. And let's go back over here. We're gonna go utilities. I'm gonna click the bottom. Don't open an Autodesk's silly thing. GNSS closure bottom and temp. Import. Boop. All right, that looks right. Now we're gonna prepare to print. Prepare to print. Let me grab the SD card. Plug that in. Okay, and let's. Looks like it didn't. Sometimes my SD card reader thing doesn't get good connection. Come on. All right, well that's thinking. Let's save the tool paths. Still not showing up. Come on, SD card. I had this kind of janky. I'll show you. This is kind of my janky adapter for my SD card, and it doesn't always like to. Sometimes it's great. Plug it in, just works. Sometimes it doesn't. Okay, well I have an alternative reader. Let me pull that out. I think it's an alternative reader. Yes. It's got one in it. How long is the print for that enclosure? 2 hours and 13 minutes for the bottom. Which will be likely longer than our stream, but we'll see. All right, plugging it in, plugging this one in. Hopefully I don't unplug anything. I crash my system. Okay. All right, I still don't have. I still don't have my no name. Where is it? Come on, show up. That one should have worked. What is this nonsense? Boy, what is the haps? We haven't even gotten to the tricky stuff yet. I'm just trying to plug in an SD card. Oh, okay. Well, maybe I will have to fight with that later. That's a bummer. I really wanted to get that printing. All right. Well, let's. Did I miss the date announcement for RC1? No, we have not announced a date yet, but I'm hoping, fingers crossed, hoping this weekend. We broke debugging. It was kind of crazy. It was a weird flash thing. There's a timing in the flash chip in it, and it was really hard to track down, but we did finally track it down, and debugging is working, though the first breakpoint to hit takes like 20 seconds. And there's a bunch of delays in there, but it is working again, and it's working better than my SD card, that's for sure. All right, let's see. Maybe my SD card has gone sideways on me. Let's take a look at that real fast, and then if I don't fix it in here, then we'll move on and I'll print that later. Yep, all I see is that one. Okay. It's too bad because I just printed the other day. Yesterday I printed those things, so should be working, but oops, don't. Yeah, still not showing up. Man, bummer. Okay, well, I'm moving on. Look at that printed later. Yeah. We don't have the machine hooked up via USB. I could hook up the machine via USB, but I don't know. Printing over USB is kind of risky. It always crashes. All right, so the enclosure is, that part's updated. I'll get that printed, and then I will work on the top. So let's get to the fun stuff. Anyway, what I want to do today is show you the hardware. So first of all, I want to talk a little bit about assembly of said hardware. So we have, as I showed you, the hardware is very cool. Here's another picture of it. And the way that we assemble this, so I purposely designed this GPS board so that you can assemble it at home, right? So all of the components are big enough that we can hand place and whatnot. And I want to show you real fast. Here is some videos that I took of our assembly process. So here is a picture of, or here's a video of Willow putting in, spreading the solder paste through the stencil onto the board. So underneath that is the GPS PCB, and she takes a little bit of paste. You can see there's a paste bucket up here. It's lead-free solder, and she just squeezes it through the holes and smears on the solder paste. And the way that these are set up, so we actually, over here on the right, you can see we have a stencil printer, and it's nice, but truthfully, this is for small run prototype stuff. I actually find that using this setup where you just take the stencil and tape it down to the desk, and underneath you use some other PCBs to make a frame to slide the item in, and this is a much easier way to set this up. It just takes a little bit of tape, and then you have a stencil. And by the way, when you order your board from JLC PCB, you can get a stencil for $7. It's insanely cheap. So I highly recommend doing, ordering the stencil when you get them, when you get your PCB created. And the only thing to know about here is stencil side. If you have a top and a bottom to your PCB with stencil stuff, this kind of confused me at first. You can get both of those on the single stencil. I always only do like single-sided PCB, in the sense that we only put parts on one side, so I just select top. But yeah, it's $7 to get a stencil, and that's incredibly cheap, because stencils ordinarily cost like $150. So when you order your PCBs through JLC PCB, it just makes it super easy to get a stencil. Okay, and then once you've got that, once you've put you set your stencil up, you spread your solder paste, and then this is what it looks like after that solder paste is on. You see it's really clean here. Puts through all those little holes, and it works out really, really nicely. And it's so much easier than using, some people use those, I think, is it Tindy? Solder paste. This thing. We've used all kinds of things, syringes and whatnot, to put our solder paste on. This thing works really well. But again, honestly, just putting, and I'll put that in here in the chat. But honestly, just ordering the stencil with your PCB is the way to go. Okay, let's play with some hardware, shall we? So right now I have the Project Lab board plugged in. I was testing that, so you can see that was working. I was testing it with the new the latest OS bits. So I am going to turn this upside down so we can get to the USB, and let's find a USB-C to plug in. So I should have the latest OS on this. I want to actually show you. Let me flash this one. So this one doesn't have the latest OS on there. So this is our second one. Put it in the thing, and let's go to my command line flash. All right, so I've downloaded. This is we're internally on 6752, so I've downloaded that. Now I'm going to flash that to this device. And in this release candidate 1, we've done a lot of work around the CLI and around tooling and deployment. So flashing is a lot more reliable and a lot easier. And by the way, just to give you a sneak peek, so in beta-developer, you can find our release notes. I just pasted them in the chat. So this is what's coming in this release this weekend. So here we are. We're downloading the OS via DFU. I wonder if I can get my SD card to work. Again, I feel like I'm tempting fate while I'm doing some other complex USB maneuvers right now, but I want to see. We'll plug it in. All right, that one still doesn't work. I've got another one here someplace on my desk, another flash card. I wonder if that flash has gone sideways. Anyway, here it is, getting updated. As you can see, it's working real well. Where's my computer? Maybe if I go to this MacBook Pro. Nope, still no flash. Still no flash drive. Let me see if another flash card works. Hey, so that one works. So I think my flash drive has pooped the bed. This one has it's a wildlife cam, so it's got like photos. All right, let's copy this stuff off. It's got photos of bears and deer and things like that. Whoa! 16 gigabytes of stuff on there. Why is that so big? Maybe we can just get the bum. So this is all old. All right, I think I have all these. This is cool. This is a wildlife cam of mine that I had out in the woods, and nothing in that one. But some of these have bears and cougars and stuff like that. Living up to the Wilderness Labs name on this one. I like a bird. All right, there's some other stuff on there that's more interesting, but let's erase this. Poop. And then I think we need to empty the trash. Empty the trash. Okay, cool. Now we got a flash card that should work. While the OS is still flashing, we'll go over here and let me see if I can get this onto the flash card. Woo! Hey, I think it actually worked. Okay, cool. So I guess I'll have to order some new compact micro flash cards or whatever. All right, I'm gonna start this printing. I want you folks to tell me if the 3D printer noise is too much. But let me get it started. Print. All right. Okay, that's starting. Cool. All right, all right. Okay, back to flashing. Camera device. I think Adrian has got some ArduCam stuff working. I think they need some updates though, if I recall. I think that camera stuff is on his list. Okay, we're on the last bits of flashing this device. Okay, so now Meadow-OS is on both devices. Boop, boop, boop. So that's good, by the way. If the fact that I was able to flash an OS means that the core compute module and the USB stuff is working. So that's like, you know, quite a bit of the hardware. Okay, I'm going to pull this one off, and we're going to work with the one without the screen to start with. Put this on, and let's do Meadow list ports. Let's try that again. Meadow list ports. Meadow device info. Meadow. Let's see. LS dev USB. No, it's TTY. TTY USB.USB. TTY.USB star. I wonder why this one isn't showing up as a serial device. Oh, what about the other one? I'm just trying to get the information off of the, just make sure that everything flashed all right. All right. Boop. This one. So that one works okay. It shows up. Maybe I didn't. Maybe that's the one I flashed the other day and I haven't flashed this one. Let's see, I'm putting it in the boot. And DFU util-l, okay. So this one, this board, it looks like maybe I haven't tested this board because I can't, it doesn't show up in bootloader mode, which makes me think, boop, boop, boop. Oh, there it is. Just probably a bad connection or something. Let's, actually I want to reset it now that I got a better connection and see. Okay, so that is not a valid Meadow device. So let me put it into bootloader mode. It's DFU util-l. Okay, so there it is. Let's see if we can flash on there. Okay, so we're flashing Meadow-OS onto the second one. And while we do that, we're going to close that and we're going to make a new Meadow app. So Meadow app, C#. And I'm going to make it in, actually what I'm going to do first is make a solution. Miscellaneous blank solution. We'll call this GNSS tracker. And we're going to put this in Sensor tracker, source, hardware, industrial design, and we need firmware. What should I call this? Firmware or like applications? We'll call it firmware. That's pretty industry standard. So then we got hardware, industrial design, and firmware. Just gonna make it in there. GNSS tracker, create. Okay, got a blank solution. How's this going? Yes, proceed. All right, bulk erase has begun. We're gonna do add new project to it, Meadow app. And we're gonna call this demo, or let's call it hardware diag. No, let's just call it demo app because it'll be both diagnostics and demo. Boop. All right, and then I've got to do something. So this is something that you won't have to do at home. I should probably make this bigger, right? Probably can't see that. Boop, boop. That's probably too big. So I have to do something that you won't have to do at home. When you're working on this, everything's published via NuGet. But for us, because I'm working on all our local develop branches and stuff, and we haven't published them to NuGet yet, I have to actually add all my references manually. So we're going to call this refs. And now I have to go in and add existing project. And this is just a little bit of, this is a little bit of tedium, but like I said, you don't have to do this, which is great. So let me see if I can remember everything that we need. We need contracts, Meadow contracts, project. Pro probably would have done this before the stream. I was too busy setting up all my streaming stuff. Okay, logging, we need that. And we need units. Add existing projects. Units. Again, this is just all added via NuGet if you're doing this at home. But, and so we got contracts, logging units. We need core, poo-poo, and F7. So we need both of those. Let's do core first. What? Am I in the wrong thing? Oh, here. Add existing project. And now F7. Okay, I think those are good. Let's see if I can build this. It should build all the rest. Okay, great. That's in. And now we need Meadow Foundation. Boop, 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 boop. Meadow Foundation core. And then we'll need, let's see, build that. Okay, good, good. So far, so good. Cool. Now let's remove these NuGet packages. Remove both of those. And add project references. If I add F7, that should bring in everything below it. And Meadow Foundation core, that should also bring in everything. Okay, so now this will, I think, may or may not build. It may build but won't run. Yes, okay, so it won't run. So this is, so it won't even build. So we've actually, this is cool. This is actually a really neat thing. Part of our release candidate 1 is that we have massively simplified the lifecycle stuff, the boilerplate, needed to spin up a Meadow app. So we no longer need our static void main, so we can delete that. So one less thing. And then, and by the way, there is a if we go to the release notes, there's in here is a lifecycle. So Meadow app lifecycle. So this talks about what we've done, and there's instructions here for how to update this. So one, we simplify this, boop, and then we have this initialize and run. So no longer do we have to have a constructor. And this is going to be, I think this board has an LED. Did I put an LED on it? It does. Oh, it does have an LED. So let's go look at this schematic, because we do have an LED on D20. So this is going to be PWM LED, onboard LED. I'm going to move this stuff into the initialize and get rid of this. This is now going to be return base, all your base. What do we return here? Is it return like new task or something? Return base. Wonder if we have that in the thing. Return base dot initialize. Here it is. Cool. All right. So this is no longer going to be. This is just a PWM LED, and we're going to instantiate it with the pin, which is device dot pins dot D20. Which is not in this one because we need to switch this to F7 core compute V2, and then we should get pins. See if D20 shows up there. D20. There we go. All right. So what else do we need? There's no argument given forward voltage. That should be a. That should be a. What, an optional parameter, I think. So there's forward voltage. I think there's a known, it's like a known voltages for forward voltage, but that's the drop over the LED. I'm just gonna call it it's a new voltage. Oh, typical forward voltage. Look at that. Dot. And this is, I think it's a green LED. I don't know. What did I put on here? Yellow green says. Yellow green. So green should be fine. Okay. And now let's get rid of this. Okay, so we're getting the PWM or the LED up, and by the way, how's that? How's the noise from the printer? Is that okay? Is that it's not crazy or anything? It's not like whining. Because if it is, I'll shut off the. I can happily shut off the 3D printer. Okay, so this, and then the final thing that I need to do here. Go into options and then set this from an executable to a library. Can't hear it. Awesome. Thanks, Julian. So this should now run on the device. So let's see. Let's see if we can build. But look at how much cleaner that is. No, no static void main, and then all we have is initialize and run. And there's a bunch of other cool stuff in here. If I type in override, yeah, lots of new stuff on air, on recovery. I think there's some sleep stuff, but I don't know where that went. There should be like on will sleep or on wake up. I don't know where that went. Maybe I'm confusing where it's at. Okay, let's see if this works. So the first time, recall that the first time that we deploy, it has to deploy a ton of like big stuff. So it'll take a few moments. So while that's deploying, actually, I'll take a real quick bio break. I didn't, when I hit deploy, I didn't even look to see if this had finished flashing. Looks like it did. Yeah, it does look like it finished flashing before I hit deploy. That's good. It's getting a little aggressive there. Jumping the gun. Jumping the gun. Okay. Here's the big one, MS Core Lib. So, one of the cool things that we've done in this release is that we've turned on linking when we built it all into the deployment tool chain. And what linking does is it takes your compiled app and it basically, imagine your app as a fruit tree. And there's a bunch of branches on this fruit tree. It's also called tree shaking. And there's a bunch of stuff on this tree that is like dead code paths, code that you don't actually use. So imagine it's an apple tree and there's, branches that have apples on it are living and then the branches without apples are dead. What tree shaking or linking does is trims out all the tree that doesn't have apples, all the tree that doesn't have code that's in your app that's going to be called. Because when you compile a .NET app, there's a bunch of like extra libraries and things like that. And we strip all that out, and Hello World with linking goes from like 23 megabytes down to 6 megabytes. And we're not linking MS Core Lib yet. So we're going to do that probably maybe in the next release, not our RC1, but in a future release, we'll link MS Core Lib as well. And that should get our full deployed app size down to just a few megabytes, which is huge. I mean, it's already very small. It's like 6 megabytes. So pulling it down to like 3 megabytes would be amazing, because then we can put it on a lot of off-the-shelf. We can then run Meadow on a lot of off-the-shelf modules, because a lot of the modules now these days, like the new ESP S3 boards, have like 16 megs of RAM, 8 megs of RAM and 16 megs of flash. So it's possible that we'll be able to run on some stuff like that. All right, app is deployed. Initialize hardware. Boop, boop, boop. You can do it. If our stuff goes sideways from here, it could be a short stream. if all my beta stuff breaks, I think we'll be able to get this up. Afternoon, Dev Nerd Chick. Minnesota, Michigan? Michigan. Minnesota's MN, right? Michigan is MI. All right, let's do... Oh, it probably did run. I never did anything with the LED. That's funny. Okay, let's do something. Let's like blink the LED. Let's do onboard LED dot start. Let's do it pulse. Let's just use the defaults. Start pulse. Okay, stop this. Boop, boop, boop. That's funny. Wasn't doing anything because I didn't do anything. Michigan. Well, welcome from the Midwest, the Middle West. Or as our West Coasters think of it, the East. Because really anything east of the Rockies is East. Just not East Coast, Mid-East. How about Mid-East? I guess that one's already taken, Mid-East. Flyover country. Julian, are you in flyover country too? By the way, is this font big enough, or do I need to like bump it up? I should probably also put in some console. Let's put some console stuff in here. Console right line. Running. And our LED is pulsing. I don't know. Can you see that? It's pulsing. Ooh, a nice little pulse. Great. Sweet. Hardware is up and running. This is fantastic. Fantabulous. Okay. So, next up, I actually want to start... Let's start getting some hardware stuff on there, right? So we've got... And I want to do something. I want to copy some code that we did in... Project Lab. So let me find our Project Lab samples. We're in develop is where it's at. Where it's at. Develop. Source. Yeah, we did this cool thing, this pattern in Project Lab that I really liked. We created this interface, Project Lab hardware, and then we put our stuff on it, and then we have this hardware class for the different versions, and in that we actually instantiate all of our hardware, and then we use that from the app. So I'm going to do something like that. So I'm going to do, and then we can make that hardware class a library that we use across to all of our apps, right? So let me see. Let's add new project. I'm going to do Meadow library. We'll call this GNSS. Meadow.GNSS tracker.core. Delete that class. my mouse button is dying, which is a little frustrating. All right, so now we need a new class. We're going to call this tracker hardware. What do we call this here? Project Lab hardware. Yeah, GNSS. Tracker hardware, create. And in here, and I think we'll need some dependencies. We need to get rid of this. Remove. And instead, we're going to add a project reference to Foundation Core. Okay, so let's go over here, onboard LED. And this is going to be a public property. Is that, how's that? Can you hear the printer? It seems pretty loud here. What's it? Public PWM LED, onboard LED, and get. I don't think I need protected set. I think I can do something. Get, whatever. And then boo. And I don't think I think I actually want to initialize it. I don't know what we did here. We've done this. We've done this a few different times. Passing those in. I wonder why we passed those in here. In any case, we need the device. IF7 Meadow device. Where's that at? IF7. This is not a Meadow device. It's a core compute. IF7 Meadow device. Where is this at? I think it's in Meadow Core. Using Meadow devices. Meadow device. I don't know if that's gonna. We'll just do this. I'm gonna do this for now. I'm gonna pass in the actual. Not an interface. Oh, I know what I gotta do. Add project F7. That's why. Because we pulled those out because Meadow runs on a lot of different places now. Had any impact sponsorship submissions? Yes, we had a really awesome one already. Super excited about that. Yeah, you should get yours in for sure. And then, all right, we're gonna private protracted. We're gonna do this. Boop. And so I'm gonna do this device equals device, and then here is going to be, and actually I'm gonna make this a private property. Get. Make it protected because somebody else might want to do stuff with it. And then we have this dot. We got capitals. This device. Okay, sweet. And onboard LED. Onboard LED equals the new thing. So do console.writeLine initializing on onboard LED. And I'm gonna wrap everything. This is something that is really good idea with hardware. Is that hardware can go sideways. So we're gonna we started wrapping everything in try-catch. Try-catch. And then depending on whether or not these things get instantiated, you know, you can do stuff in your code. Catch console, right line, error, instantiating, initializing. Cool. And if it worked, then we're going to say onboard LED initialized. And up here, we're going to do initializing hardware. And now let's add a reference to this. Man, I love having full .NET running on an embedded hardware device. This is so cool. Okay, so let's get rid of this. We're going to say GNSS tracker hardware. And we need to get that using. And we'll do boop, boop, boop. Hardware equals new hardware. And we're going to pass a device. And then this becomes hardware dot onboard LED dot start pulse. And you guys are gonna laugh at me. So I really, for a class level variable, I really like this, but I get in trouble for doing that. So that's why I'm gonna do I'm gonna make this a property. There we go. All right, because it's already protected. Cool. And now we get hardware. What's it say? Cannot be assigned to its really. Oh, right. There we go. All right, we've got now our hardware abstracted out into a class. Let's see if this works. Yes, it is. My first microcontroller was one from a decade ago. Yeah, my first one I think that I ever used was the Basic stamp from Parallax. Great company out of at the foothills of foothills of Gold Country down in Netduino. Yeah, Netduino was pretty rad. We've come so far from Netduino. So far from the micro framework days. Yeah, man, full .NET. Remember how in Netduino you couldn't use generics? That always killed me because we use generics everywhere in Meadow to make it make the API beautiful, right? Ooh, look at that! Up and running, pulsing, fantabulous. Okay. What else should we pull up? Let's pull up the BME 688. Let's see if that works. This should be interesting. Okay, let's go back to here. And again, so what you would do in your own app, you would go manage NuGet references, BME 68X, and then you would do this and add package, and then it would be super easy and rad. But I've got to go add the source. So this is in Meadow Foundation, peripherals, was it atmospheric, sensors atmospheric, BME 680. Cool, cool. And while I'm there, let's go look at how to bring Meadow Foundation. All right. This is one of the coolest things about Meadow Foundation is that you just come in here and you find your driver, and then not the driver, samples, BME 688 sample, and here it is, like how to use it. Create I2C sensor. Boop. Cool. So we're gonna need our I2C bus, I2C bus, I2C get boop, and then I'm gonna do a little cleanup here. And then we're gonna do I2C. And hopefully it doesn't go sideways here. I would not be surprised actually if it did, but I'm hopeful that it won't. So I2C equals device dot create I2C bus, and I think we're good with just the defaults. Which I2C did I put? So this is interesting. So this is fun. The core compute module has multiple I2C buses. I think so. This is I2C1. So I shouldn't have to. So in this you can do like bus number, bus number 2 or whatever, but we shouldn't have to do that. All right, so let's see if we can get our I2C bus up. Boop, boop, boop. Stop running this. Okay, built. Deploying. How's everyone's Wednesday? Hump day? Okay, deployed. Starting up, connecting. Connecting some more. Well, this is where we've been cleaning this up, why it connects, why it has multiple. All right. Woo, all right. Very cool. I2C worked. Fantabulous. Now let's bring up the BME 688. So we need a BME 688. BME 688. Let's see, using, did we forget to add a reference again? I think we did. It's got to think for a little bit. All right, let's see. Using foundation dot sensors dot atmospheric environmental. Is it environmental? I thought it was. Let's see. Where is this BME? What's the foundation sensors atmospheric? So is it still just trying to find it? Oh, I know what I did. I put it on the wrong one. It's in the core. There we go. Now, I should find it. There we go. Sweet. I did click that, right? All right, my mouse is dying. Okay, BME 688. Ooh, I wonder which address I have it on. So let's look. Where is it? BME 688. So we're pulling the address. I think that's SDO. Chip select. Yeah, SDO. So we're pulling it to ground, so it should be 7.6. Cool. And I2C. 222, 222. All right. Let's test it. What is trashed? Dealing with identity server issues. Oh no! I'm sorry, man. Microsoft has a lot of good technology, but identity server, not just identity server, but like the identity stuff at Microsoft is worst in industry. You know, there's the .NET is best in industry, and their identity stuff is worse. Their SSO is so bad. So I'm sorry. I'm sorry that you're having to deal with that today. That's tough. Okay. BME 688. Woohoo! Yay! I wish I had a button. Oh man, I have to show you folks this. I have one of these. I got this Razer Loop Deck stream controller, and it is amazing. But you know, I need a button on there that when things go well, that like stuff flies across the the screen. Wait, I have a... Could you hear that? Could you hear the badum-tis? Okay. All right. I don't know. Did that? Could you guys hear my badum-tis in the applause? All right. BME 688's up. How have you not swapped out the control? Right. I kind of want to. I kind of want to build one. Very cool. Okay, so BME 688's up. Now let's do some stuff. So we got I2C bus up. We've got the BME 688. Let's start updating. Let's start getting some information from it. And I am going to. I don't need a filter. We have two ways to do. By the way, I'll paste this in here. There's two ways to work with our. There's three ways. There's two main ways to work with a sensor. You can do a one-off read. So all of our sensors are like this eye updating sensor. You can do a one-off read where you just call sensor.read, and you can await it again because we got full.net, so you've got async await. No exception means up. We need a temp reading. Yes, so we'll get that. So we can just do a one-off read, or we can do we can start it updating, and then we can get notifications. And there's two ways to get notifications. One, you can use an eye observable. So if you're into reactive stuff, you can do an eye observable, and you get a result. And then you can also do an optional filter. And this is cool. This is super rad. So let's say I wanted to only get notified when the temperature moves a certain percentage or a degree or something. We can actually set this filter, and we can do a conditional. We can do a Boolean expression, and if the condition is met, then the observer pops up, which is so powerful, just so powerful. Because that, otherwise you can just get a lot of noise. The other way is to just do an event and subscribe. So we're going to use that one to start with. So I'm going to say run, start pulse, and then I'm going to say if hardware.bme is not null, is something, then we're going to bme.updated plus equals boop. Oops. And let's see, on updated. Let's get rid of the gas conversion stuff. I'm going to rename this to results. And I don't think we need all this stuff in here. I think there's a way to, sender, result. So let's do that. Let's do, whatever, it's fine. So we're going to say if that's good, then BME start updating, and we can specify some intervals here too. We can say look, update an update interval. There's also other things. We can specify other update information, but let's say let's update every 2 seconds for now. And actually it's not. Did we update that time span? Yeah, so time span. I love units from seconds to. That's cool, right? Default is 5 seconds, but we want a little bit faster just for right now. So I think everything would be good. Let's deploy this and run it. Man, think about how fast this has been. We've updated the enclosure. That's printing, and then I started a brand new app. And even with having to set up all these project references manually, we're already got hardware up, and it's doing stuff. And it's been like an hour. Pretty cool. Wemo, good afternoon. Wemo. That's like a self-driving car. I guess that's a Waymo. Look at that. Here we are. We're getting information. We get temperature, pressure, humidity. So it is 25 degrees Canadian. That's what that C stands for if you're unaware. And 38% humidity, which makes sense because we got some moisture coming in. And we're at 1 atmosphere, 988 millibars, or a lot of pascals. Damn! Amazing! Okay, so next, let's get this GPS up and running. And I actually don't know. We changed around the GPS stuff. There's actually a GPS driver between. So should I be able to copy this project minus core project ref using NuGet with my Klima? Yes, I think you should be able to actually, more or less. Although I think the Klima, in Klima there is. Oops, that's not what I wanted. I think in develop, we'll see. Where's Jorge updates? Yeah, develop has, or maybe it's Jorge updates, actually has all this stuff. We haven't merged it to main yet because it's all based on the new. It's all based on the new RC1 stuff. So honestly, I would wait until this weekend until we get RC1 out. So you wanted to start with Hello World rather than the big project. Yeah, that makes sense. Okay. Let's get the GPS sensor in. So I'm going to add existing project. We're going to get the driver. And again, this should just be a NuGet for you. Peripherals, sensors should be under location, I think. Light, load cell. I don't know where it's at. Hey, Jorge or Adrian, if you guys are watching, do you know where the new GPS driver is? Atmospheric distance. GNS, here we go. Oh, MT3939. That's not actually the one that we want. Okay, so we don't have I don't think we have... Actually, I'm curious if that is the same. Let's go into... So we're using a U-Blox Neo M8. And I'm not sure. I think this... GNSS. I think this MT399 might be the same driver. Nemia, sentence, serial port. Decoders. I think this one will work. I think because all this is, and actually this is an idea for the team. We should take all the Nemia stuff and put it into a GNS driver base, because all of the GPS drivers will use this Nemia stuff. So we have a Nemia, we have a NMEA, which is a nautical something. National Marine Electronics Association, and it's the way that GPS sensors give out their information is a series of sentences, they call them, and then we just decode it. So everything that's in this driver is basically all this like so we get these sentences and then we decode them. So all this is like a shared thing. Anyway, let's just go and add this and see if it works. MT3339 is MediaTek. If this doesn't work, we can make one. We'll make one real fast. Okay, add a project reference to this GPS thing. And now, let's go back to our hardware. And we need to initialize the serial port. Device serial port COM4. Cool. So we're going to say public GNSS. And this is going to be the MediaTek 3339. Oh, I got it backwards. Boop. Okay, device and then serial port name. So GNSS equals new MT33 device. Actually, device. Is there a lowercase device in here someplace? Oh yeah, in the thing. And then serial port name, which is going to be device serial port names. And I think it's on COM4. Let's find out. E-paper, COM4, RxTX. Where's our COM4? Okay. So, and let's change the update on this. We're going to do 10 seconds now that we know that that works. Initializing GNS. Okay. And then we've got the stuff received. Let's just see if we can bring it up. Just uploaded all the new driver stuff, the NMEA processor and all that. And this is so smooth. So good. It's really amazing because the last month has been a real struggle. After we broke debugging and the flash stuff was weird. So that we're all up and running again is amazing. Oh, by the way, this release RC1 has everything's JITted now, so everything's super fast too. All right, GNSS initialized, so no issues there. Cool. It's too easy so far. Too easy. So now let's get some information from the GPS. So we'll go back to the Meadow app and see if hardware dot GNSS is not null. Call it GNSS. Boop. I have to start updating it or anything. Yes, GPS start updating, and then so we subscribe, and then we do GNSS dot start updating. And I should probably plug in my antenna. So I have this GPS antenna, this long ass thing that snakes up. Let's see, it snakes up my wall. There it is. It goes up and then through my garage door and then out onto my roof. That's my view outside. That's where the birds come and hang out. Alright, so let's plug in our antenna. This is going to be kind of a moment of truth because recall when we did this antenna stuff, I really have no idea what I'm doing, and from an antenna design perspective, but I actually think it'll work. Okay, let's just let's send that off. So you really can't hear the printer, huh? Surprises me. It's good microphone and filtering, I guess. It's a high pass filter, low pass. I'm not actually sure. Okay, connected. Sounds like a low noise fan. Okay. So you can hear it now, but it's not bad. All right. Just Big Harris. Big Hairs. Good afternoon. Okay. Start output antenna info, asking for release and version. I don't know what that's about. Where's that come? Oh, that's from this stuff, I think. Turning on all data. So I don't think we're getting GPS data. Are we? Did start updating. What else do we got to do? So we subscribe, initialize it, subscribe, and start updating. Let me see what else is going on in here. Boom, boom, boom. That's all. Nothing specific to the empty serial port. Get release and version. Ah, these things. So these are. This is in this driver. This is the only thing specific to this GPS chip. So there's this commands PMTK. So this is MediaTek. I don't know what we need to do with the with this GPS to get it to start. I could go look at the data sheet, but rather than spend some time in that, let's do something else right now. I'm gonna comment the GPS out, and I want to save. I want to try. I want to do something crazy. I don't think we've tested this yet, but I want to use I want to start logging. I want to start logging some temps. So it's, yeah, so explore the sample app. Configuring the database, tables, data types, adding data. Okay, let's set up. Oh, look at that bug, the little UX bug, how small that is. Okay, let's go to Meadow app, and we're gonna do startup. I want to add, yeah, I want to add SQLite. So I need a model. Demo app. We'll call this tracking model. Boop. And then we need to add the NuGet for, am I in the, here we are. We need to add the NuGet for SQLite. And I can't remember if, I think we can just add the regular SQLite. I don't think we have to do anything Meadow specific, but let me go back to the thing. SQLite net static. SQLite net static. I wonder if this is actually deprecated. Meadow. Okay, so maybe we're good. So let's see, SQLite net static. Hey, there we are. Okay, so that one, we added that package. And now should be a using SQLite. Perfect. Okay, now we want double, I'm gonna say temperature Canadian value, like double relative humidity percent. And then pressure, oops. Public double pressure, and we'll put that in atmospheres. Atmos. Pressure atmos, right? Is that what it is? It's like 1 atmosphere. So temperature, humidity, pressure, ID, and timestamp. Okay, so that's our thing. So we got that. And then context. So this is where we set up our database. So we'll call this new class. Call this Meadow-DB context. By the way, it's been a long time since I've used SQLite in here, so we'll see if this works. I have high hopes. Okay, DB context. Microsoft Entity Framework Core. I wonder if that's where that comes from, this DB context. Entity Framework Core. if we need to add that package, we should add that to our docs. But let's see, maybe it's not in a. Okay, so I just want to make sure if I look in this project, it should tell me if that's a package. SQLite, no. All we got is SQLnet statics. So where does that come from? I think it's been a while since that sample's been updated. Alright, using SQLite dot. There's DB context. It is EF. Yeah, but I don't understand why I don't see a package reference to anything EF. I just see the package reference to SQLite net static, which tells me that it should be it should be in there, right? Go back to the Fouget, by the way, is really cool. So the same guy who created SQLite.net, the ORM, Frank Kruger, created Fouget.org. And Fouget allows you to browse an assembly. So I am going to look for what is DB context. Nothing, no DB context. All right. Fouget.org. Oops. SQLite. What's it called? Net static. System.data entity, huh? Where's the... database handler, private SQLite connection. So I think that's the way that it's done now. Public DB set, sensor info, DB, path. If we get, see if we get any of these other ones. DB context options builder, no. This is actually tracking model. DB set. All right, so I don't want to take a reference entity framework yet because I think there's a way to do this without that. Let's copy this stuff in. Actually, how are we doing this in the app? Are we... That's not the one. Where's our sample? Meadow app. SQLite connection database. Let's start with this. Let's go to Meadow app. SQLite connection database. Okay. Configure database. I wonder if we're even using that context class. I bet we aren't. I bet this context is nothing. I bet it's just in there and not being used. I bet that's what's tripping me up. Okay, configure database. In fact, I want to do, let's do add class. Database controller. And I want to do, let's do static for now. But we can do a singleton later. So public static void configure database, which is thread safe. If you need to change that, you can do it the following: single thread. Database goes in the data directory, MySQL database, MySQLite database, database, okay. Our database. Public database. Ah, right. Static. Create table. And this is going to be tracking model. Okay, create the table, tracking model, and if the table's already there, it will not create it, so that's good. All right, so we got our database, and then, ooh, there's a lot of cool stuff. Forgot all the cool stuff you could do. Database is up. And now, so configure database. Let's start with that. So let's do go to our initialize. Say bring up the hardware. Bring up our database. Database controller dot database controller. Different namespace. Okay, database controller, configure database. And we're going to do console dot write line. Error, bring up database. E.message. Okay, oops. So the team has confirmed on Slack that I was looking at an old file that is no longer used when I was looking at that weird context file. So that's why I got confused. All right. So we've got the, let's see if this is, let's make sure I got everything. So configure database, and then, all right, so let's push this and see if the database gets created without issue. And while that's deploying, I'm going to use a quick bio break. All right. Visual Studio has connected. Error bringing up database. Cannot create a table without columns. Does tracking model have public properties? Tracking model. That's a good question. Public. All right. Table, sensor readings, public class tracking, primary key, auto increment. Let's go to the database controller. I think we need to do create table. Cannot create a table without columns. Does tracking model have public properties? Create table, tracking model. Okay, let's go back to this. Configure database. Database path, make a connection, create table, sensor model. And what does this sensor model look like in here? Sensor model. Table, sensor readings, sensor model, primary key auto. It looks right? Sensor model, sensor readings. Sensor model, public class tracking. Oh, I know. It's tracking model. That's why. Where did this come from, though? What is this? Oh. That's. Found the error. As Christopher Tacky would say, the error is somewhere between the keyboard and the chair. Why do we have tracking model? Yeah, that's a copy paste error. Oop. Okay, this should work now. Stop this. I like this big font. It's easy. It's easy on the eyes. So I'm looking down at this little screen, you know, the output stuff. I'm like, boy, that's small. Oh, hey, look. It worked. We've got a database. We should probably give some indication that we brought it up, though. Database controller. Let's do a... Yeah, right. Trey says, glad you didn't set this up beforehand. It's good to see I'm not the only one to make such errors. Yeah. Bringing up database. And then we'll say console right line database up. Okay, now we have some indication that that's happening. Let's go here, and let's write some data. So I'm gonna collapse this GPS stuff for now. On updated, let's create a new sensor reading. So tracking model equals tracking model. And we're going to say temperature C equals result dot new dot temperature dot Celsius, and why didn't like this? Bum bum bum. Cannot from double to double. Oh, I wonder if SQLite will handle this. I don't know if it will. Relative. What's it? Humidity. What's the thing? Relative humidity percent. Oh, I know why. I need a comma. There we go. Humidity and pressure atmos results dot new dot pressure dot standard atmosphere. Okay, and now we're going to save that. What's this one? To double, right? So this is dot value. What is this? It's coming in as relative humidity. Value. What's the? How do I get that? Dot percent. Sweet. That should work. And now we need to save that to the database. So how do we do that? Update, insert dummy data. Take the first, update it. So database.insert. All right. Database. Wait, what is this database? SQLite connection database. I don't think I'd do that in here, right? Because that's all it's in the database controller. There we go. That would have been a funky thing. Database controller database insert tracking model. Okay. And I am going to clean some of this up. I'm going to do console.write, and we'll do comma, comma, and then finish it off with a right line. So this will be to console write line. Saved to saved sensor reading to database. And then after I've saved it, I want to actually get the data out. I want to make sure that it's going in. I want to make sure that it's going out, going in. So I'm going to make a method called read data back. And I'm going to we'll go back over to my sample app, retrieve data. I need to do this. And that's actually a better retrieve. Retrieve data. Did I spell it right? No. I before E. Except after C. Unless, of course, it's in retrieve. Database controller. Tables. Tracking model. Reading was R dot. Temp C. Into what's the into C. Okay, let's read back the temperatures. So retrieve data, and then I want to do like I'm gonna start a task that retrieves this. So you know what? Let's just retrieve it after every time we put it in, just for the heck of it. Right now. Okay. So let's see if this works. Okay, bringing up the database. Interesting. So it's giving me an error in here, but it does look like it's saved it. Interesting. My time's off, of course, because I have never set the time on this. I could connect to an NTP server and then get the time. But so we have to figure out why we're getting that error. But it does look like it's actually working. So this is very cool. Hey, all right, rad. Okay, well, I think I am going to, the cable was created with not nullable, but schema is now is with nullable. That could be why. I think maybe it could be why, yeah, because it says, well, no, it should get updated. So the SQLite.net is pretty robust. It should, if you change the schema, it should actually put the right, it should fix it. So I'm not sure what that error is, but we'll look into it. We are still beta. All right. Very cool. Well, I am really excited. So today we fixed our enclosure. Well, we fixed the bottom part. I still need to fix the, the alignment of the display. Oh, we should bring the display up. That's cool. Yeah. Let's deploy this. Let's deploy this to the other, to the one with the display, because I haven't done that yet. So unplug this one. I guess we're not using the GPS. I don't need to worry about the antenna right now. Okay, plug this in. So we do have a driver, I think, for this e-ink display. We just added it. So let me add, actually while we're doing this, let me deploy the app because it's going to take a bit to get it deployed. Do. Alright, let's try this again. Unplug, replug. I recall one of these had kind of plug issues. Doesn't want to connect to this one. Should actually see the LED on the power light up, but it's not. Although I think we got the LEDs backwards on some of these. Still not connecting. Let's see what's going on here. Meadow. Let's see, list. Was it ls dev usb.tty star. Oh, tt.tt. Okay, so it's showing up there. So, let's see, Meadow, use port. This one. Okay, Meadow device info. Connecting. Okay, so it's communicating okay. So why? You know what? I'm gonna restart Visual Studio. All right, building. Let's see if we can deploy it on this one now. There we go. I just had to kick Visual Studio. It's probably our bug, truthfully. It's probably not a Visual Studio bug. We're probably, when the devices are switching, we're probably not clearing something. Okay, sweet. So all that's deploying. I want to add our... I want to add the driver for the display, which is in Meadow, Foundation, Peripherals, Displays, e-paper. I don't know if that's wave share or not. It's a wave share driver. To ask Adrian. Adrian, is this Adafruit 2.13 a wave share display? I'm not sure if it's a wave share or not. Let's go to boop 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 peripheral driver library e-paper. .13. So it looks like it's EPD 2" 13. Okay. So maybe that's the one I need to add. We actually redid some of these. We made wrappers for the wave share ones, but I'll just add the regular. And then the wrapper automatically instantiates some stuff correctly for you. You know what? I'm going to add the wave share and see what we've got for drivers. EPD 2" 13. Yeah, it's one of these, and this is the triple color. So I think it's the... I don't know if it's the B or the V4. Let's see. 213. I don't think this is updated. This V4 3-color display. Which one's 3-color? SPI. I don't know which one it is. I'll do. They're different, and they're different. Different chips. That's interesting. Okay, what's it complaining about though? What does it want? It needs... It's got dependency on displays.epaper, so we got to add that. So foundation, peripherals, displays.epaper, and then micrographics as well. So we should refresh. That should show up. And now we need the micrographics. Again, if you're doing this yourself, you just add the NuGet. But I am... Okay, libraries and frameworks, micrographics, driver. All right, so we should have everything. Refresh, boop. So this, let's see if this builds. Build e-paper. I guess I should wait for this to stop. Looks like it's having a hard time connecting to this Meadow. I wonder why this one... Why? I think it's something's up with the USB. Let's stop it. Unplug it. Replug it in. And let's try to deploy again. Okay, uploads to the device. I wonder what this... I'll take a picture of this driver and it'll tell me. If I take a picture of this chip on this e-paper display, then I'll know what driver it is definitively. Actually, this is not the... It doesn't have a chip on it. The driver chip, I think, is not there. I think it's under the... I don't think I can see it. Because the chips that are on here are not the drivers. It's like the SD card reader and stuff. Okay, cool. So this is working on the second board now. I think I just had a bad... I think it's USB-C, honestly. I think the cable just wasn't good. Okay, so that's working. So let's stop this. Let's build our wave share. Let's make sure it works. And it says NuGet package needs to be restored. What NuGet packages? Maybe I need to rebuild. What NuGet package? Where's my package thing? Let's see if I can build displays e-paper. Okay, so that one works. Which means micrographics worked. So e-paper, let's clean. What do you mean I can't clean it? Refresh, restore. Hey, all right. Looks like we're good now. Build that. SSD 1680. I'm not sure. That doesn't sound right. Yeah, they have a great selection of e-paper displays. All right, well, let's brute force it. Let's just try them. So let's go to our app. Let's create a display controller. And again, we'll just do static for now. Later on, we can singleton these. Initialize. Static void initialize. Okay. And go away. Cool. Oh, Seagull's working. Very cool. Let's go to peripherals. Let's go to our displays. E-paper wave share. Not driver. Samples. Boop, boop, boop. Oh. So you're creating, initialize a display based on the display switch. Oh, cool. All right. Display type. Not sure which one it is. Get display. Wonder how, where's this get display? Get display. Oh, I see. It's a switch to instantiate. Okay, so we need this, one of these. So I think I'm gonna do this in our hardware, actually. So we'll do SPI first. And I think I'm going to make this a public, actually, because we're going to use this. Not yet. Not yet. Create that. So it's going to be SPI equals device.create SPI bus. And which SPI did I put this on? I think I just put it on the main SPI. SPI 3. I think that's... Can't remember. Speed. Bus number 3. Okay, so that is the default. And... I think our frequency, I wonder if there's an SPI dot, like known frequencies, supported speeds. Look at that, that's cool. I want to make it fast. I want to make it 48,000, 48K. But let's just do it whatever right now. SPI. Okay, and now e-paper. And we don't know which one of these it is yet, but EPD. So e-paper, what are we calling it? We're not calling it anything. Public. What type is it? Let's go back to the e-paper wave share. This is just e-paper tricolor base. E-paper display. Gotta use add project reference. E-paper wave share. And now there we go. So let's create it. E-paper display equals new. Chip select pin. What is the chip select pin on this one? Chip select is EPAP chip select D02. And the data command pin is D03. Reset pin is D04. And the busy pin is D05. Okay. So that is our e-paper display initialized. And then we're gonna, in our display controller, not database controller, let's close this, display controller. Let's say display private static e-paper display. When we initialize it, we're going to pass the display This is going to be our canvas. And it is rotated actually 180 degrees. But since we've got it, we actually have it plugged in. I got this turned upside down. We can just ignore this for now. And then we want to draw something. So I'm just going to draw anything. Let's do canvas, blah, blah, blah. And then we're going to do canvas dot draw or clear. Is it a clear? Clear. And then let's pass it. I think we do a color, but there's only 3 colors. I'm not sure how to use the e-paper display. I'm not gonna lie. Red, black, white. I think let's do color dot. Let's do what happens if we do color dot black. Color dot black. Color. Using color.black, and then let's draw some stuff. Okay. Let's see if this works. Hardware, so this is where we bring it up. Should be okay. Here, initializing e-paper display. Let's go here. So that hardware is brought up in the hardware here, and then I want to do initialize display controller initialize, and we pass it hardware dot e-paper display. And then, all right, let's see if this works. Oh, look at saving all our readings. Look at how close that is. The readings, that's pretty, I think that BME 6088 is pretty precise. I have to wrap this up soon. I gotta go get a COVID booster. I think it's my 4th shot. I think it's my 2nd booster. I'm not sure how many. Well, we've got a lot done today. We've got basically a whole app. I'm pretty excited, and we're saving. So we're initializing all the hardware. Well, the display controller, we're working on that right now, but we're initializing hardware. We're taking readings. We're saving to a database. This is really like a productive, pretty good, pretty productive stream. All right, e-paper display, initialize, yeah, database stuff. Okay, so it brought up the e-paper display, or at least it thinks it did. Let's go to the display controller, bringing it up, initialize. So this should be drawing some stuff. So I don't think it's actually doing that. Let's try the EPD 2-in-1-3. Oh wait, look, it did something. It's doing something. I don't know what it's doing. Look at that. It's got something. Okay, this is good. Look at that. It's got, I think it's trying to write the text, but it's, let's see if I can, let me prop this up. This is the only glare. Okay, fantastic. Okay, so I think it's just the wrong display. So let's try this one. Boop, boop. Where else do we have that? It's in hardware, right? And then, okay, so let's see if this one works. I bet it's this B. I think the B is the one with the 3 colors. I don't think this one is a 3 color. Yeah, I think it's this one. I think it's B. Yeah, 3 color SPI 104. Okay, so let's put this one in. 23B. I wonder if there's a base. There's got to be like a base class. Oh yeah, clear screen white, and then Texas printing black as well. Oh, you're right. Well, some of them are red, black. You're right though. Well, let's see if this one. Let's see if this one works. I'm excited. We've come so far. This is kind of like, I really like rolled the dice on this stream too, because I didn't even know if the hardware would work. But so far, everything has worked except for the GPS, and I think that will work. I gotta write some different commands to it, because we're writing a different GPS driver set of commands. And I want to speed up the SPI. Okay, so let's go to hardware tracker. When I create the SPI, I want to create this with 48K. Frequency, speed. And there's like a known So device.spi, what is it? Capabilities.sp. Somewhere in here is the SPI speeds. Hey, look at that! It worked! It's rotated, but it worked. All right. Before I screw up the speed, let's fix this. So that one worked. Very cool. Okay, let's do. We're gonna clear this to white, and then I'm gonna rotate this. I guess it does need to be rotated. Look at all the readings. We're just stuffing that database full. Okay, so we got this rotated. Can you guys read the, can you see the, let me see if I'll, boop, 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 boop. See, it did something, but can't make out what it said yet. It says, yeah, I zoomed in now. You can see it's this color and then white. And by zoom in, I mean I push the camera forward. I can't get my, I have a cam link, which is this thing, and I can plug my DSLR into it, but I can't get it to work with my Mac M1. I'm actually surprised at how much stuff, we're like 2.5 years in on Apple Silicon, and I'm surprised at how much stuff still doesn't quite work with Apple Silicon. It's kind of crazy. Hey, look at that. There we go. Meadow F7, color, black, white. Okay, this is very, very cool. So, we're going to add a method to our display controller. What's going to be public, static, void. And we're going to say display, we're going to say update conditions. And I'm going to go back to Meadow app. Stop this. And we're going to do kind of want to pass this whole tuple and then figure it out in there. I change result. Yeah, let's do this. Update conditions. That fat tuple. Tuples wobble, but they don't fall down. Okay, so canvas. We're going to clear the canvas. And then we're going to do... I think we're already good with the font, but... and then I'm going to draw some text. And I think, what is this? XY? XY. So XY. I'm going to do X. It's a 16 font. See what happens. Y of 2. And we're going to say temperature. Let's do temp. And black. And more. 2 and 40, 20. We'll do temperature, pressure. And I'm going to do, instead of millibar, I'm going to do, let's do standard atmospheres. I think this has to be, let's see, 16, let's do 18, plus 20, 38, and 58. Humidity. Temp, humidity, and pressure. Okay. So we got that. Update conditions, and then show. This one, I'm going to say, when we update the display the first time, I'm going to do 2. Hello, Meadow. Okay, and now, bring that up. Let's actually not... I kind of need to be smart about this. I need to do a render loop where if it's still rendering, I don't write it out. But I think just to be... I think to hack it right now, I'm just going to reduce our update stuff. Okay, so we're going to do, once we get the BME updated, we're going to do display controller dot update conditions result. And then I'm going to do this every, I don't know how long it takes, but we'll do every 20 seconds. I also want to try to make this faster because I know that that display will update much faster. I know that we, okay, frequency equals new frequency. Type hertz 48 123 unit type dot. Ooh, I can do 48K. Okay. So I think that's, we're maxing out the speed on that. Let's see if this works. Okay, so while that, happy path. Yeah. Okay, I'm gonna use the restroom while that's just going. All right, it's going. So question for y'all if we put these in the store as like, you know, follow along with our coding or whatever, that, you know, we'll do multiple revisions of these. But if we put these on this in the store and just said, hey, these are beta trackers, beta things, if you want to follow along as we release new versions, would you guys be interested in having them? Should I put them in the store? Oh yeah, hello Meadow. And then hopefully it's less than 20 seconds to update that. Oh heck yeah. All right. Well, there's the answer. I guess we'll have to put these in the store. All right, updating. All right, so Dev Nerd, Chick, and Juliana, you guys are down for an order. The problem is that they'd have to be kind of expensive because we don't. It's such low quantity, so they'd probably have to be $150 or something is the challenge. As long as you do the soldering ahead of time. Yeah, for sure. Did I write these in white? So it cleared out. Where's it? Display controller. Black, black, black. No, I wrote it. So why didn't it update with this? Oh, there it is. I am doing something crazy. There we go. Temp, humidity, pressure. Woohoo! Look at that. Ah, fantastic. Okay, well, this was a really good stream. We got a lot done on this today. I'm really excited. Let us check in our stuff. Oh, I need to add that to the git ignore. So let's go in here. What do we call this? The GNS tracker. Where's it at? GNSS sensor tracker. Let's go ahead and do the git ignore. Let's open this up. Boo boo. .ds_store. All right, let's see if that fixed this. Okay, sweet. Don't check that in. Actually, uncheck everything. Added ds store to git ignore. Push that. Sweet. Is this already checked in? Is that why? Do I have to delete that manually from the thing? I think I might. Let's go here, GitHub, GNSS, sensor tracker. Yes, it's already here. Let's delete this file. Okay, any more DS stores? Yes, all the DS stores. So there gonna be a bunch of these? No. Where? No. This one. Man, look at that display. It's still updating. I love it. Delete Mac. Garbage. Let's copy that because there's clearly a bunch of those. Okay. Source. Oops, I already went through that. Docs. Okay, I think I got them all. I think I got all of the DS stores. Let's fetch this. Following file source. Yeah, let's discard the change on that. Discard that one. Okay, and now we can check all this stuff in. We'll say initial app setup. Oh yeah, on the BME and watch it change. Maybe I could breathe on it. I don't even know where it's at. Okay, I'm gonna breathe on it. That should change humidity and everything. All right, pushing all those changes, and then while we're here, we also want to. I haven't done the top yet, but I do want to save out. Oh, what's it say? Probably already cooled down or whatever. I want to save out the new. I want to add the new STL that I created. So in temp for the bottom. Okay. And then I should probably, let's export this. I haven't fixed the top yet, but that's all right. We'll at least get this part in. GNSS sensor tracker source, industrial design, boop, export. Okay, so it's actually, this is the file name. So boop, boop, there we go. So we'll say updated bottom. We'll give an intoxication report. Not, unfortunately, not the BME 688. Updated bottom to fit antenna underside solder. PTH through hole. Cool. All right. Well, with that, that was a great stream. I'm really excited that worked. Yeah. Our hardware worked. Yay! And the screen's updating the display, and pretty cool to see how quickly we could spin up a whole app running on some cool hardware. And it's all, like battery-powered stuff. So thank you, everyone, for tuning in. And I can't remember if I'm streaming next week. I think next week I will be in... I can't remember if I'm coming. I think I'll be in Seattle next week, so it might be the week after. But I'll let everyone know. So thanks everyone for tuning in. You've been an awesome audience, and I super appreciate everyone coming and saying hi and chatting. So until next time, adios.